So in this video, I'm going to talk about the Euclidean algorithm. And the purpose of the Euclidean algorithm is to find the greatest common divisor. Um, I'm going to briefly go over basically the basic idea of the Euclidean algorithm so that it can kind of like help you understand where it's coming from. And then we'll go through and I'll do some demonstrations of the Euclidean algorithm so you can see how it actually is done. All right, a little bit of practice, you'll master this. Okay. All right. So the basic idea here is let's suppose I have A and it equals B plus C. Okay, where A, B, and C are integers. Okay, now what the idea here is that if A and B share factors, okay, if they share any factors, then B and C are also going to share those factors as well. All right, that's the idea. Okay, because basically, like you imagine that if I find out that I have a fourth letter D, D divides A, and D divides B, okay, then D has to divide C as well. It's got to, all right? And so consequently, what we're going to do is we're going to continually utilize this fact in order to go in and find the greatest common divisor, all right? It's an iterative process that will allow us to find the GCD. So let's take an example, and let's say, for example, I want to find the GCD of 71 and 36. Okay, you may already know that 71 is prime, and so consequently, it's not going to have a it's the GCD between 71 and 36 is going to end up equaling 1. But it's always good to be able to actually check this out. Okay, so what we're going to do is we're going to start out with the division algorithm, and we're going to divide. So we start out by dividing 71, okay, by 36 using the division algorithm. So 71 equals 36 times 1 plus 35. Okay? Now, the thing is that if the greatest common divisor for 71 and 36 is also going to be the greatest common divisor for 36 and 35. So what I'm going to do is then I'm going to divide 36 by 35. So we now get 36 is going to equal 35 times 1 plus 1. Great. Well, now the GCD of 36 and 35 is also going to be the GCD of 35 and 30 and 1. So 35 is going to equal 1 times 35. And now I'm done, okay, because I've now found that greatest common divisor. The greatest common divisor of 35 and 1 is 1. So, right, the GCD of 71 and 36 is 1. Or the way that we write it is GCD 71, 36 equals 1. So here's how the algorithm works. You'll start out by doing division, divide 71 by 36, or our first number, our larger number divided by the smaller number, all right, using the division algorithm. Then you're going to divide the divisor, right, by the remainder, okay, and then you'll reiterate that process utilizing the divider and the remainder again until finally you end when the remainder is 0. The GCD, okay, the GCD is the final divisor in your final division. And that's the Euclidean algorithm. Let's do it again. Now let's find the GCD of 153 and 126. Okay, so I'll start out utilizing my division algorithm. I'm going to divide 153 by 126. So 153 is going to equal 126 times 1 plus 17. Excuse me, not 17, but by 20 plus 27. All right, now I'm going to divide 126 by 27. So 126 is going to equal 27 times 4 plus 18. So now I'm going to divide 27 by 18. 27 is going to equal 18 times 1 plus 9. And now I'm going to divide 18 by 9. So 18 is going to equal 9 times 2. And notice it's now plus 0, so that ends the algorithm. Great. And so what that means is that 9 is the GCD of 153 and 126. So that's the Euclidean algorithm.